So what I'm going to do is I'm going to jump into our material library and I'm going to throw down a Karma material builder. Just like that, I'm going to say Karma Cloud Material Basic. And then I'm going to dive inside. I'm going to delete these. And I'm going to throw down a Karma Pyro Shader. And I'm going to plug in the volume here. And then we need a properties, Karma material properties. I'm going to plug that in here. Cool. Now, this is just a very basic shader. So what I'm going to do is, it's now we've assigned the preset material to our cloud. So I'm just going to call this assign material preset, and I'm going to duplicate it, and I'm going to call this basic. Go. And I'm just going to go and grab the basic material. And then I'm just going to disable this one. So now if we render, you'll see that we have a new shader on it, and it's just the default Pyro shader, and it doesn't look very good. So let's open up our film roll here, and I'm just going to disable this one, and then re-enable our preset material so we can get this. And then I'm just going to take a snap and then disable that material and enable our basic material. And I'm just going to take a snap. So now if we double click this, we can look at the difference. So you can see here's our nice cloud material. Here's the Karma Pyro material. And how do we get this to look more like this nice cloud shader? So we're going to jump inside our material library, go to the Karma Cloud material, the basic version, and this is just the default Karma Pyro shader. To get started, the two biggest things are our anisotropy and our extinction fall-off. Now, if I just go to our extinction fall-off and change this to 0.21, we should start to see that we are getting some better scattering. And if I just take a snap here and we take a look, this is the default. You can like look at the dark edges that we're getting on our shadows. And then if we go to the one where we have adjusted the extinction fall-off, you can see that those shadows disappear. And what extinction fall-off is doing is it is basically exponentially decreasing the density with each volumetric ray bounce. So what does that mean? It means that every time that a light ray bounces within the volume, it adjusts the density of the volume and exponentially decreases that towards zero, so that we start to get some better scattering and our shadows aren't as thick and dense. Now, the next component to this is our anisotropy. And what anisotropy is, it's basically telling the ray which way to scatter once it enters the volume. So a high anisotropy level means that the cloud is forward scattering. So the light ray is coming in and then it is bouncing it towards the camera. And if we look at our default, our preset, it's got an anisotropy of 0.877, which is kind of like the default cloud value. Our extinction fall-off is 0.21, and now you can see the roughness is set to 1. So if we go over to the basic shader that we're setting up and we enable roughness, and now you'll see that we get the same result as our preset shader. And what is happening here? So if we just hit snap and we check our renders, you can see now that we're getting that nice scattering through the volume, and it should match our preset shader. So what is happening here with our roughness? Now, just like our extinction fall-off, our roughness, it exponentially decreases the anisotropy with each volumetric ray bounce. So every time that the light ray bounces within the volume, the anisotropy is decreasing exponentially towards 0, which gives us this nice cloud shader. Sweet. So that's just a quick breakdown on if you want to create the cloud shader from scratch. This Karma Pyro Shader is very powerful and it's great for rendering clouds. Now, if you want to take it one step further with me and actually see how to set up all of these functions manually, then stick around, because what I'm going to do is I'm going to duplicate our basic material here, and I'm going to create a new one called custom. And I'm going to go back in and I'm just going to disable roughness, turn off our anisotropy, and turn off our extinction fall off. And if I go back up, and I can now go assign material, duplicate this, and we can call this one custom. And then again, I just need to change this to be custom. Well, that's what we've named it. And now if I hit render, you'll see that we're back to this volume, which is not getting any ray bounces or anything like that. So let's jump into our material library. Let's jump into our custom material. And so I just want to give a big shout out to Samuel Krug, who originally developed this method inside of Blender to get really nice, realistic cloud renders. And what we're going to do is basically port the same things that he has been doing into our Houdini scene. So there's nothing really new, and essentially this Karma Pyro Shader is doing all of those wonderful things. But when I first started playing around with it, I wanted to see how easy it was to replicate Sam's method of rendering clouds from Blender, and create the same setup inside of Houdini. Again, huge shout out to Sam, because without Sam, our clouds would not be looking so epic. So to get started, let's throw down a null. Yeah, I'm just going to disable our render, throw down a null, go to this property panel here, say edit parameter interface, and I'm just going to throw down a bunch of float values. So we first need our density. I'm going to say density. And then we need density gamma. And then density fall off. So I'm just defining the parameters that we are going to play around with and create a little control that will be easier to make changes with. I'm going to say anisotropy. Just going to hit Control S to save. Remember. And I'm going to call this control. And then let's change the color, make it nice and red so we can see it. And now we have all of our different values. So I'm just going to quickly set this up. I'm going to say the density is 1. Density gamma will be 1. Our fall off will be 1. Anisotropy 1 will be 0.877. Let's keep the fall off at 1. And then our anisotropy 2, I'm just going to leave it at 0. And let's make this 1 as well. So if we just throw down a parameter, I'm going to call this density. Just like that. And then I'm going to link this, right click, say copy parameter. We go to this parameter and say paste relative references. Nice. Cool. So I'm going to now duplicate this so that we have a bunch of parameters. I'm going to say density gamma. So now we can plug our density I'm just going to open up the smoke option here. Now you can see that we have our density scale parameter exposed. I'm going to plug the density into our density scale there. Now, what we need to do is modulate our density based off of the ray depth of our light rays coming into the volume. So what we can do is we can throw down a ray, Karma ray import. Now this node accesses some different properties of our ray, like the light ray that we are emitting. And what we need is we need to grab the ray hit level. So just like that. Now this is going to calculate our ray depth entering the volume. And what we're going to do first is let's just set up our density gamma. We can throw down a power operation, and I'm going to plug this in. And let's just give this a render. So you can see nothing special is really happening. If I take this down to 0.1, you can see our density is getting less and less. And I'm just going to plug in our gamma just to make sure that this is all working. And if we increase our gamma, you can see that we can start to crunch up our values. Using the gamma. It's basically just like a gamma function, which allows you to harden the edges a little bit. So we'll just leave it like that. So we can kind of, it's just some extra control. So we'll leave it at that. So for our fall off, we need to multiply our ray depth with our fall off. I'm just going to turn this off for now. So now we're modulating the density fall off by the ray depth. I'm going to throw down a power, and I'm going to plug this into the exponent. I'm going to plug it into the exponent, and then for our value, I'm going to say 0.5. And then we are going to multiply our density based off of the ray depth. Now, if we render, you can see that we have gotten rid of our ray badge shadowing, like we did see in the first time we kind of set it up. So if I plug that in, you can see that we have these really dark shadows here. So we have successfully recreated our extinction fall-off with some nodes that we have additional control over. That's it for the density. And what we need to do now is adjust our anisotropy and get our roughness going. So I'm just going to turn this off, and we're going to create another parameter, just like this. I'm going to call this anisotropy 1. And then I'm going to duplicate it, call this anisotropy 2. Call this anisotropy 2, anisotropy 2. And then for our anisotropy 1, we need a fall off. This one fall off. And then anisotropy 2 needs fall off as well. Cool, so we have all of our parameters. I'm just going to link these up quickly. So anisotropy 1. So let's plug in our anisotropy, and if we go over here, you can see we have an anisotropy input. And now if we hit render, you can see that we have our anisotropy enabled, but now we need to modulate it with the ray depth in order to get it to look and feel like a nice cloud shader. So in order to do that, let's disable our render. So in order to do that, we need to multiply our ray depth with our fall off value. And then we're just going to throw down an add. We're going to make this a value of 1. And then we need to throw down a power function. And we're going to take our anisotropy 1 and feed the result of our ray depth modulation into the exponent. And then we're going to plug this into the output. And as soon as we do that, if we go to Karma here, you can see that we now have some decent scattering going. Now our fall off is 1. If I adjust our fall off and go to 0.5, you can see that we now have a bit of control over how much of an influence the anisotropy is having. So if I go to the fall off of 0, it's just going to give us our same kind of value here. If we just go up to 1, it will give our the full result of our modulation. But you can see that the cloud is still quite dim. So if I go to the density fall off and lower that to 0.5, you'll see that we now get a brighter cloud, still with that nice property of our ray depth modulation. And then if I hit a snap, and then if we view this, you can see that the result is now very similar to our preset render that we did. So I think to continue to go down and make it brighter, if we just take our density fall off and go to 0, you can see that it's not going to modulate the density via the ray depth anymore. And it basically gives us the same value as the, or it basically gives us the same result as just the default shader. But as soon as we bring up this density fall off to 0.1, you can see that our shadows are still quite defined. I feel like a value of 0.25 is pretty good. You want to use this density fall off just to control the like how quickly and how far the density falls off to 0 as the ray continues to bounce. So I find like 0.25 or 0.5 is a good value. But you can see now that we have essentially recreated the functions of this Karma Pyro Shader, but outside in nodes. And we've created a little null over here with some parameters, which just gives us some extra control over our volume and our cloud shader. So you can see that even in the default shader, there's use secondary anisotropy. And essentially they built this roughness channel to mitigate having to use this, because when you do use a secondary anisotropy, it can result in higher noise. I'm just going to duplicate our entire function here, and then I'm going to plug in our fall off 2 value and our anisotropy 2. And then what I'm going to do is I'm going to take the result of this and I'm going to plug it into secondary anisotropy, just like this. And if I hit render, nothing's really happening because we haven't enabled it. So I'm just going to let this resolve quickly. And let's just take a snap there. And now if we enable our use secondary anisotropy, you'll see that we get a bit of a brighter cloud. And now that's just because our secondary mix is set to 0.5. I'm going to set this up to 1. And if we take it down to 0, we're now basically mixing between whether we want anisotropy 1. If the mix is at 0, we're just using anisotropy 1. And if it's up at 1, we are just using anisotropy 2. Now, we don't see much of a difference because our anisotropy 2 is just set to 0. So if I take this really high to 0.98, you'll see that we get like a very flat kind of volume. What we can now do is now, if we want a mix of that, we can set it to 0.5. And now we're using half anisotropy 1 and half anisotropy 2. And using this can result in some really nice properties that we give to the cloud. You can see that it's not overly bright. and you're getting a bit more of these more grayscale values kind of within the density. So it is definitely worth playing around with. Now, let's just let it resolve quickly, and let's take a snap. Cool. So we have basically recreated the functions that come default in our Karma Pyro Shader, but we have created this null node to give us some extra control over those parameters and how it works within our volume. So the last thing that I want to show you is how to manipulate where on the volume that these properties are placed and how you can customize that. So if we throw down a position, is a material X position, and if we throw down a material X separate vector 3, we can now plug in our position and we can now get the X, Y, and Z components. I'm just gonna throw down a range node, material X range, and plug in our Y value. And I'm gonna say from 0 to, let's say, a height of 20, we're going to remap it 0 to 1, and now we can throw down a ramp, a Karma ramp parameter. So now we can plug this ramp into, let's plug it into our smoke color. So I'm going to keep this as an RGB color ramp, and let's just plug it into our color for now. And if we hit, so I'm just going to disable secondary anisotropy, and let's just hit render. You can see now that our ramp is being applied to our cloud, and we can start to kind of adjust things and where this is being applied, which is great. So I'm just going to disable our camera. So now we can kind of move around and see what's going on. So now that we have our position-based ramp working, so if I throw down a unified noise and grab our position, and then just plug this into the smoke color, and let's change it to, let's say, cell, copy these parameters, and if we go to like 0.1, you can see now we have some noise running through our post-process. Now we have some noise being run through our volume on a shader level, and you can now use this to mask some of these properties just to give some variation to the cloud. And it does give some very nice results. If you start to modulate things and change the properties, it definitely helps when it comes to realism. So let's just plug in our ramp again. So we have this ramp, and I'm going to switch it to a spline ramp. And I'm just going to reverse this. So we have this, something like this. And now instead of plugging it into the color, let me just disable this. We are now going to use this to adjust our secondary mix. And what I'm going to do is keeping our anisotropy really high. Let's go back to our camera and let's hit render. And now you should be able to see that the bottom of our cloud is using a very high anisotropy level, and we start to get this kind of dimmer, more grayscale values within our density. It gives us a very nice quality to the cloud, and it gives us a little bit of variation. If I take a snap of this, so if I take a snap of that, and then if I disable our secondary mix and just use it at 0.5, and if I take a snap, now if we compare the two, you can see that we have introduced a different quality to the base of our cloud, leaving the top of our cloud nice and bright and synonymous with what we see in large-scale cumulus clouds. But you'll notice, see how much noise that we're getting. And this is what kind of happens when you use secondary anisotropy. And depending on the value that you have added, it can get very heavy with noise. So last but not least, I'm going to show you one last thing, that if we right-click on our Pyro Shader, say allow editing of contents, and we dive inside, you'll see these are all the things that are making up our volume. We've got our secondary anisotropy and roughness over here, and then some of the scattering and emissions that we don't really need to worry about. And what we are going to do is we are going to throw down a input connector, and I'm going to call this, let's call this ramp. Then let's call this mix. And then I'm just going to multiply these two together. Ramp goes into 1, the mix goes into 2. I'm going to set our ramp just the default value, which will be overridden over here. And then what I'm going to do is I'm going to plug this into our extinction modifier. So since we aren't using extinction fall off here and we've kind of created it ourselves, we can use this extra parameter to drive some things and help get rid of that noise. So if we go to our Pyro Shader, and if we open up the other section here, you can see there's our ramp and there is our mix. So I'm going to plug our ramp into here. And then I'm just going to create a constant. And let's set this to 0.5. And I'm going to plug that into our mix over here. So now let's enable our render, and you can see that we are modulating our cloud using our ramp. And I'm just going to let this resolve. And now if we take a snap, you can see that we are getting a similar result, but without that crazy amount of noise. And then we can use our mix to say how much of that effect we want to see and how little we want to see. So there's a whole bunch and there's a little bit, but we don't have that noise. And that brings us to the end of this tutorial. In the next video, I'm going to be taking you through the rendering aspect and going over the Karma render settings node in a bit more detail, rendering out some AOVs, and then compositing everything back together inside of Nuke. So thanks for sticking with me. I'll see you then.